Life on Earth is a marvel, a tapestry of extraordinary diversity. From the towering redwoods to the tiniest insects, our planet teems with an astonishing array of life forms. But have you ever wondered how this incredible variety came to be? The answer, my friends, lies in the fascinating process of evolution. Evolution is the driving force behind the diversity of life on Earth. It is a process of gradual change, occurring over countless generations, that has shaped every species on our planet. Through the mechanisms of natural selection, life has adapted and diversified, filling every conceivable niche on Earth. The story of evolution is a tale of survival, adaptation, and the relentless march of time. It is a story that continues to unfold even today as species respond to the ever-changing challenges of their environments. Join me, dear viewer, as we embark on a journey to explore the wonders of evolution and unravel the mysteries of life's grand tapestry. At the heart of evolution lies a simple yet powerful mechanism: natural selection. This process, often described as survival of the fittest, drives the adaptation of species to their environments. But let's delve a little deeper beyond this simplified phrase to understand the true elegance of natural selection. Imagine a population of animals, each with slight variations in their traits. Some individuals might be faster, have sharper claws, or possess better camouflage. These variations, however subtle, can make all the difference in their struggle for survival. In the relentless competition for resources and the constant threat of predators, those individuals with advantageous traits are more likely to survive and reproduce. They pass on these beneficial traits to their offspring, who, in turn, are more likely to thrive. Over time, these advantageous traits become more common in the population, leading to the gradual adaptation of the species to its environment. Variation is the raw material upon which natural selection acts. It is the diversity within a population that provides the fuel for evolution. Without variation, there would be no differences for natural selection to favor, and evolution would grind to a halt. This variation arises from the very building blocks of life: genes. Genes are passed down from parents to offspring, carrying the instructions for building and maintaining an organism. However, genes are not static entities. They can undergo mutations, which are random changes in their DNA sequence. These mutations can introduce new variations into a population, some of which may be beneficial, some harmful, and many neutral. It is this constant influx of new variations that keeps the gene pool dynamic and provides the raw material for evolution. Nature, my friends, is an unforgiving judge. It is a crucible in which only the fittest survive. This selection pressure, exerted by the environment, is the driving force that shapes the course of evolution. Individuals with traits that make them better suited to their environment, such as camouflage, speed, or resistance to disease, are more likely to survive and reproduce. They are the fittest in the Darwinian sense, not necessarily the strongest or most aggressive. Their offspring inherit these advantageous traits, and over time, these traits become more common in the population. Conversely, individuals with less favorable traits are less likely to survive and reproduce, and their genes, along with the traits they encode, become less common. This relentless process of selection, operating over countless generations, leads to the gradual adaptation of species to their environments. Section 5. Inheritance, passing the baton. The continuity of life, the passing of the torch from one generation to the next, is ensured by the remarkable process of inheritance. It is through inheritance that the genetic blueprints for life are transmitted from parents to offspring, carrying with them the legacy of adaptation and survival. When organisms reproduce, they pass on their genes, encoded within their DNA, to their offspring. These genes carry the instructions for building and maintaining an organism, including the traits that make it well suited to its environment. However, inheritance is not a perfect copying process. Mutations, those random changes in DNA sequence, can occur during the replication process, introducing new variations into the gene pool. These mutations can be beneficial, harmful, or neutral, and their fate is determined by the ever-watchful eye of natural selection. Section 6. Darwin's finches, a study in adaptation. Few examples illustrate the power of natural selection as elegantly as Darwin's finches. These unassuming birds inhabiting the Galapagos Islands provided Charles Darwin with crucial insights into the mechanisms of evolution. Darwin observed that finches on different islands, despite their close resemblance, exhibited striking variations in their beak shapes. He hypothesized that these variations were adaptations to the specific food sources available on each island. Finches with beaks well suited to cracking large seeds thrived on islands where these seeds were abundant. Conversely, finches with slender beaks, adapted to probing for insects, flourished on islands where insects were the primary food source. These observations led Darwin to conclude that natural selection had favored finches with beak shapes best suited to their environments, leading to the evolution of distinct finch species. Section 7. Antibiotic resistance evolution in action. Evolution is not a process confined to the distant past, it is happening right now before our very eyes. One of the most striking examples of evolution in action is the rise of antibiotic resistance in bacteria. Antibiotics, once hailed as miracle drugs, are losing their effectiveness as bacteria evolve resistance to these life-saving medications. When antibiotics are used to treat bacterial infections, they exert a strong selection pressure on the bacterial population. Bacteria with mutations that confer resistance to the antibiotic are more likely to survive and reproduce, passing on their resistance genes to their offspring. Over time, the population becomes dominated by resistant bacteria, rendering the antibiotic ineffective. This rapid evolution of antibiotic resistance poses a significant threat to global health, highlighting the importance of understanding and addressing the evolutionary processes at play. Section 8. The gradual march of time. Evolution, my friends, is not a rapid or sudden process. It is a gradual and stately dance, a waltz through time that unfolds over countless generations. The dramatic transformations we see in the fossil record, the emergence of new species and the extinction of others, are the culmination of countless small changes, accumulating over vast stretches of time. The Earth, our home, has witnessed immense geological and environmental changes throughout its long history. These changes, occurring over millions of years, have provided the backdrop against which the drama of evolution has unfolded. Species have had to adapt to shifting continents, changing climates, and new competitors and predators. Those that failed to adapt, those that could not keep pace with the relentless march of time, were consigned to the history books, their stories preserved only in the fossil record. Section 9. Genetic diversity, the fuel of evolution. Genetic diversity, the variety of genes within a population, is the lifeblood of evolution. It is the raw material upon which natural selection acts, the fuel that powers the engine of adaptation. A population with high genetic diversity is better equipped to cope with environmental challenges and adapt to change. Imagine a population facing a new disease. Individuals with greater genetic diversity are more likely to possess genes that confer resistance to the disease. These individuals are more likely to survive and reproduce, passing on their resistance genes to their offspring. Over time, the frequency of resistance genes increases in the population, providing a shield against the disease. Conversely, a population with low genetic diversity, where individuals are genetically similar, is more vulnerable to disease outbreaks and environmental changes. Section 10. Evolution's unending story. Evolution, my friends, is not a story with an ending. It is a continuous and ongoing process, a never-ending dance between life and its environment. As long as there is life on Earth, evolution will continue to shape and mold the diversity of species that grace our planet. Even today as we speak, species are adapting to the challenges of a rapidly changing world. Climate change, habitat loss, and the introduction of invasive species are just a few of the pressures that are driving evolution in the 21st century. Understanding evolution is not merely an academic exercise. It is crucial for addressing the challenges facing our planet and preserving the incredible diversity of life that makes Earth so unique. Section 11. Conclusion, a legacy of change. As we conclude our journey into the world of evolution, let us marvel at the sheer elegance and power of this fundamental process. From the tiniest microbe to the largest whale, every living organism on Earth is a testament to the relentless creativity of evolution. Evolution, through the mechanisms of variation, selection, and inheritance, has shaped the tapestry of life on Earth for billions of years. It is a process that continues to this day, molding and shaping the diversity of species that grace our planet. Let us remember that we too are part of this grand evolutionary saga, Our own species, Homo sapiens, is a product of evolution, shaped by the same forces that have shaped every other living organism. As we continue to explore the wonders of the natural world, let us do so with a deep appreciation for the power of evolution and the interconnectedness of all life on Earth.